Hello friends, subscribe our channel Learn Mathematics, press the bell icon and be the first one to watch our new videos. Friends, today we are going to do very important theorems on mathematics. The theorem is Pythagoras Theorem, which is very important, and the application of Pythagoras Theorem is applicable in all branches of mathematics. Therefore, the theorem today is, in a right angled triangle, the square of hypotenuse is equal to the square of sum of opposite sides. Now, in a right angle triangle, one angle is 90 degree, and the opposite to 90 degree is the longest side of the triangle, which is also called hypotenuse. Now here we have to establish the relation between the longest side and the two other sides of the right angle triangle. So let's make a right angle triangle. This is right angle at A, B, C. For example, this is a triangle, right angle triangle at angle B. Now, what we have to prove, now here, the opposite of this 90 degree. This angle is 90 degree, the opposite of this 90 degree is AC, which is the longest side and is also called hypotenuse. Now we have to prove the square of this hypotenuse or the longest side is equal to the square of sum of other two sides. Other two sides means AB and BC. So now you have to prove. Given, what is given? ABC is a right angled triangle. ABC is a right angled triangle. Now what you have to prove to prove the square of the hypotenuse. That means AC whole square is equal to the square of the sum of opposite side, means other two sides, sum of other two sides. The square of the sum of remaining two sides. So what are the remaining two sides? AB and BC. So AB whole square plus BC whole square. These are the two remaining sides. AC whole square is equal to AB square plus BC square. You need to prove. Now constructions. What you can draw in the constructions from B? You have to draw perpendicular on AC. So draw it. Name it D. Now perpendicular drawn means this is 90 degree, this is 90 degree, and this is definitely 90 degree. Now construction. BD perpendicular to AC is drawn. BD perpendicular to AC is drawn. Now, proof. Okay. Now, this triangle, in triangle ABC and triangle ADB, there are two triangles. One is the biggest triangle, one is the smallest triangle. You take the small triangle. In triangle ABC and triangle ADB. Now let's try to prove it similar. Now ABC and ADB, in both the cases angle A is common. So you can write therefore angle A is equal to angle A, region common. Common in both the case. And another one. Now, this angle B is the greater angle, 90 degree, and similarly this is angle 90 degree. So, this angle B is equal to angle D. The reason same. Angle B is equal to angle D. Why? Both are equal, because both equal to 90 degree by construction. Both equal to 90 degree by constructions. So now in any two triangles, if two pair of angles are equal, then those two triangles are similar triangle. What is through the criteria angle postulates, these two triangles are similar. Now you can write therefore triangle ABC is similar to triangle ADB. And what is the reason? These two triangles are similar. The reason is, the criteria is angle postulate. Through angle postulate, these two triangles are similar. Now, in any two triangle, ABC and ADB, in any two triangles, if these two triangles are similar, then what we have learned in previous theorems, that the ratio of their corresponding sides are equal. Now you have to find out the corresponding sides. Now, what is the corresponding sides of AB? The corresponding sides of AB, now see here, in the bigger side AB, here in the small triangle the corresponding side is AD, right? This is the corresponding sides of AB in a bigger triangle, and the corresponding sides of AB in the small triangle is AD. So therefore, AB by AD equals to, therefore AB by AD equals to, now AB by AD equals to, now what is the corresponding sides of what is the corresponding sides of another one? We have already found out these two correspond, the ratio of the corresponding side. Now it is equal to, now what is it equal, what it is equal to? You have to see the triangle. One, the biggest triangle is triangle ABC, and the smallest triangle is triangle ADB. So what is the other corresponding sides? What is the other corresponding sides? Now AD by, so what is the corresponding sides of, suppose for example, what is the corresponding sides of AC in the bigger triangle? AC by what is the AC? AB. So this is the corresponding side, the corresponding side of the, we took the side of the bigger triangle, and what is the corresponding of this side in the small triangle? AB. Now you can cross multiply, or AB into AB, AB into AB, how much? AB square is equal to AD into AC remains same, AD dot AC. What is dot? Into. So this is equation number 1. This is equation number 1. Now similarly you can take triangle, two triangles here. Again another part of the triangle ABC and triangle BDC. So you can take this triangle, now I will rub it out. Equation number 1, you have marked it. Now in triangle, the bigger triangle is triangle ABC and triangle, what is the another triangle? Triangle, this part, small part, triangle BDC. Now let's try and make it similar triangles. Now in triangle ABC and triangle BDC, what is common here? In BDC, angle B is there. In angle ABC, angle B is there. That means B is common. Angle B is equal to angle B. The reason is common. Okay? And now this angle D is 90 degree and this angle B is 90 degree. So what you can write? Angle B is equal to angle D, both equal to 90 degree by construction. Both equal to 90 degree by construction. Now, with these two criteria, these two triangles are similar. So therefore, triangle ABC is similar to triangle BDC. Now the reason is angle criteria. Now again, if these two triangles are similar, the ratio of their corresponding sides are proportional, as I told you. Now What are the corresponding sides in these two triangles? What are the corresponding sides of these two triangles? What are the corresponding sides? Now check this triangle ABC and triangle BDC. What are the corresponding sides? What are the corresponding sides that you can take? AB, what is the corresponding sides of AB? If you take it in the larger triangle AB, what is the corresponding sides of AB? BD. If you take AB, then you have to take BD. One is AB by BD equals to another corresponding sides. Another corresponding sides AC by another corresponding side. What you can take another corresponding side? Suppose AC. What is the corresponding sides of AC? What is the corresponding side of AC? BC, right? BC. So now you have to put. Okay, I delete this. Now therefore, now you have to write the property of these two similar triangles. So once the triangles are similar, the ratio of their corresponding sides are proportional. So how do you write it now? How do you write it now? Suppose what is the corresponding sides of BC? BC. What is the corresponding side of BC? DC. The corresponding sides of BC is DC. Is it clear? BC in the larger triangle and DC in the smaller triangle is equal to now is equal to what you can write? Corresponding side AC. AC by, now AC is in the larger triangle, and what is the corresponding side of AC in the smaller triangle? BC. AC in the large triangle, in the small triangle. Now you can make cross multiplication as we have done, and the reason you can write here corresponding sides, as I told you, the reason is the ratio of the corresponding sides of similar triangles are proportional. You can write corresponding parts of similar triangles. Okay, now cross multiply BC into BC. BC square is equal to, now when you multiply DC into AC, AC dot DC, this is equation number 2. Now this is equation number 2. Now what? Now we are in the final step. Equation 1 and equation 2. When you add this, your theorem is proved. Okay. Now the last step now, adding equation 1 and 2. Adding equation 1 and 2. Add equation 1 and 2. What is equation number 1? Unknown. See, when you add equation 1 and 2, left hand side and left hand side will be added, right hand side and right hand side will be added. Now see, what is on the left hand side now? Equation 1, AB square plus, and the left hand side equation 2, BC square is equal to, now in equation 1 and 2, what is there? AD into AC. AD into AC plus, in equation 2, AC dot, AC into, dot means into BC. So now, or okay, let's write this on the left hand side. Now what is common here? AC. If AC is common, within bracket AD plus DC is equal to, now this will remain as it is, AB whole square plus BC whole square. Now, or AC into, now AD plus DC. What is AD plus DC in this diagram? AD plus DC, when you add AD and DC, it is AC. So AD plus DC you can write AC. AC is equal to, this will remain same, AB square plus BC square. Now AC into AC is, AC square is equal to AB square plus BC square. This is the thing what we are going to prove. AC square is equal to AB square plus BC. See what you have to prove. AC square is equal to AB square plus BC square. So this is called Pythagoras Theorem, hence proved, QED. So this is very important, and this Pythagoras Theorem is applied in different branches of mathematics from till higher level. Thank you very much.